Okay, good morning, 6 years. Just wanted to pop on a video correction of a couple of the problems that I'd asked you to do on Monday. So I had asked you to do question 1 to 4 here, and I'm going to run through corrections for all of question 1. I'm doing one part of question 2, and I'm doing question 3, because if you can do each of those, then you should have no problem with the rest of them. So first one, as we can see, question 1 is giving us two graphs, so part 1 and part 2, and we've two different cubic graphs because we've got that swoop or that kind of N-shaped curve, so it goes up and down and up again, and that's a cubed function. Okay, and it says that in it we've got two cubic functions. So for each function we have to write down the range of values for x where the function is decreasing and where the function is increasing. Okay, so if we think about the values of x, all right, so what we want to do is that if we have those things, we're looking for where the values of x, where the function is decreasing. So if we think about it, whereabouts on the x-axis is the x value going down, or whereabouts is the x value going up for part B. Okay, so we can see in the curve that from here to here the x value is decreasing. Okay, and we can see in two instances then, from there to there essentially, and from there up is where the x value is increasing. Okay, so we can see those parts on the graph. So what we want to then talk about, if you guys look, I'm going to swoop into where I've got my question done there. Okay, so as I've said there, you can see it says x is decreasing on the graph from -2 to 0. So you can see that when we go from -2 at the red dot down to 0 is where the x value is decreasing. All right, and then you can see here where it's increasing in part B. So when I go from -2 to 0, that's where the x value is decreasing in the graph, because the curve is going downwards as we go across the x-axis, or as we move across the x-axis. That's where the x value is decreasing. Now the x value is increasing in two parts, as I've written here. Okay, and if you look at your diagram, if you look at your graph and the question, you can see that it increases in two parts, from -3.2 up to -2, and from 0 to 1. Now what we have written there, you can see where I've put the little star for part A. This is the way that we'd usually draw it, or the way we'd usually write our answer. We'd usually write -2 is less than x and x is less than 0. So we are saying that the x value is decreasing between -2 and 0, because x is in between those two values, and that's what we're saying there. Okay, so that's the way to write your answer in those instances. So you can see I've done it for part A, and then I've done it again for part B, and you've got two parts. Same idea for part 2. We'll go back and we'll look at that graph again, and you can see the graph for part 2 now on the right hand side here. We're doing the same thing. We're looking for where it's decreasing and where it's increasing. So again, I'll go for red. The x value is decreasing as we go from 0 down to 2 on the x-axis. So from here to here on the x-axis, you can see that the curve is going in a downward shape. So that's why x value is decreasing between 0 and 2 on the x-axis. It is increasing, you could say, anywhere from there, I suppose, to there, and then it's increasing again from there up to there, or a little bit before it, maybe there. Sorry, I can't be as accurate as I need to be with this. So that's what's happening, and we can see that the graph is increasing, or the curve is going upwards in the spots, or in between the green spots in that case. Okay, so to tie in my answer, as we've said, there, it is decreasing between 0 and 2, as we discussed, and it's increasing from maybe minus 1.5 to 0, and from 2 up to 3 or 3.2. So if you match looking at that answer that I've written there with the graphs, you should be able to see what's happening. Okay, in question 2 then, we're given a graph, or we're given a function I should say. Let's turn this off and let's move down. Sorry. So question 2, the question asks, find the range of the values for x for which the following functions are increasing. Okay, so we're given a function, and I've done part 3 because that's the longest one really. Okay, so I've done part 3 as a correction that we're going to look at now. So we're given a function. This one is a cubic function. What I need to do, I need to first and foremost find the first derivative. When I find the first derivative, it shows to me where the function is increasing. Okay, so if I get my first derivative, and then I use that first derivative to find out x values, that will tie in what's happening. So I'll show you what I've done first and foremost, and then I'm going to match it to GeoGebra because I put the two graphs up, and you can see them there in a second. So we've got this part 3. I've got my function 2x cubed minus 9x squared plus 12x minus 5. And as I've said there, the function is increasing when the f prime of x, or the first derivative of the function, is greater than or equal to 0. Okay? So I've done my first derivative, going from the 2x cubed to 6x squared, from minus 9x squared to minus 18x, and plus 12x to plus 12. I can use that value, the f prime of x, and as I said, I've written there, I can factorize this to find the x-intercepts. So you can see I've put it equal to 0, and then I can factorize it to find x values. Two different ways you can do this. I did it this way because I was running out of room on the page, but you could put the 6x squared minus 18x plus 12, you could put that into your minus b formula if you wanted to. Alternatively, what I've done there is I've divided across by 3 first and foremost to make it easier to work with, and then I've factorized it. So I got factors of x squared, factors of 2, and I put them into our brackets, and I was able to figure out from that x is equal to 2 or x is equal to 1. So what we are saying then, if I go back to the second line written here in the problem, the function is increasing when the f prime of x, or the first derivative, is greater than or equal to 0. Now I've figured out where x is. X is 2 or x is 1. If I draw onto this graph here, I've drawn a very quick example of what the graph should look like. It's an x squared graph because my function, or my first derivative, is x squared and it's positive. So that's giving me the smile shape, or the U shape, because it's a positive graph. And I know that x is equal to 1 or x is equal to 2 based on my factorization. So I can see that the curve hits the x-axis at 1 and at 2. Now, if we see that, you know that the x value is increasing from 2 onwards. And you can see that there, okay? It's greater than or equal to 0. So from 2 onwards, we have the x, or we have the graph increasing, or the function increasing. Okay, so you can see what the question asked then. It says, find the range of values for x for where the following functions are increasing. Okay, so again, if I go back to where I was, you can see that the function is going back up from 2 onwards, and the function is also positive from 0 to 1 on the x-axis. So what we can say is then, we can finish that off by saying the function is increasing where between x is greater than 0 and x is less than 1, and x is greater than 2, because underneath the line between 1 and 2 on the x-axis, the function is decreasing, it's going, okay? So that's the way to do that one. And as I said, if you you can look back at the question, or the answers at the back of your book, and you can match them up and see how that suits. But that's the way to do those. So you should be able to answer the rest of that question too, hopefully using that information. I'll just show in what the graph specifically looks like, and you can see it there. Okay, so for question 2, part 3, I've drawn the two graphs on GeoGebra, and I would suggest or urge you to practice using that as well. So I've just typed in, okay, the first one was the one that I got. That gx is the red one, and that's from the first derivative, so the 6x squared minus 18x plus 12, and you can see that they cross the x-axis at 1 and at 2. And the other one, x squared minus 3x plus 2, is when I divided by 6, and they also cross the x-axis at the same points. You can see that they look differently, but they still have the same x values. So that's showing me where what x is equal to in both of those graphs. We still have the x squared, they're still positive, so I'm still getting that smile shape or that U shape, and you can see that that's what they are there for. Okay, really handy tool to use. I would strongly suggest using GeoGebra while you're answering these questions, lads. So last one then, if I go back again, we're looking at question 3 before we finish off. Nice and simple one, and the discussion or the explanation that we've used in the previous part should hopefully help you with these. So question 3, it says that we've got the graph of a quadratic function h, okay, and that's the red curve, and we can see it's a U shape, and so that's a smiley shape or it's a positive shape. So I have a positive x squared value based on what's going on there. I don't know the specifics of the equation. I don't know if it's x squared or 2x squared plus 6x or anything like that. I just know that it's an x squared function and that it's positive because it gives me that U shape or that smile shape. The question is asking, when I derive this function, when I get the first derivative of this function, is it looking like A or is it looking like B? Okay, so nice and simple then to tie off with that. State which one it is and justify your answer. Okay, so we'll go back to what I've drawn and we'll see it again. So question 3, you can see the graph that was given to us is similar to the one I've drawn at the top of the question. Okay, as I've written there, the smile curve, it's a U shape or a smile shape, therefore I've got a positive x squared graph. All right, when I get the derivative of this graph, it will give me the slope, because we've done that in all of the previous questions. We derive something, we get the first derivative, and if it's equal to the slope, so we can use that to figure out whatever we want to. Now the derivative is the slope, okay, it is equal to the slope, and as we said, because I've got a positive x squared graph, it means that the slope is going to be a positive value. So of those two, A or B, I've got a straight line in both of them, but I've got one pointing up the hill and one pointing down the hill. So up the hill, I've got a positive slope. Down the hill, I've got a negative slope. So A is the positive slope and B is the negative slope. So A gives me my positive slope, therefore that's the one that is correct, and that's the graph. That's what the graph will look like when I derive from the quadratic function at the top of the page down to the first derivative, and it'll give me a graph that looks like part A or graph A there. So that's our corrections for those. I'm posting this up to YouTube now, and then I'll give you a couple more to do. Minima and maxima is the next thing that we have to look at. Thank you very much.